In this video, we're going to cover section 7.2 on the introduction to substitution and elimination reactions. So, alkyl halides commonly undergo two general types of reactions, substitution and elimination reactions. So a substitution reaction, it will involve a nucleophile. And so when an alkyl halide is undergoing a substitution reaction, the nucleophile will replace the halogen. So you can see in this example, here we have an alkyl halide, which shown here is a generic nucleophile, and the overall net chemical change that we observe is that we no longer have this carbon X bond. It's replaced by a nucleophile carbon bond, and our leaving group, our other species left over after this reaction, is the halide. Now, when a similar alkyl halide is treated with a base, as shown in this example, so when we have another alkyl halide which interacts with the base, what we observe is an elimination reaction. In an elimination reaction, what is eliminated or lost is a hydrogen from the alkyl halide as well as the halogen. And you can see in this example that our major product, what we're actually interested in undergoing, is the formation of this new alkene. The base has picked up a hydrogen atom, so there's a proton transfer as a part of elimination. And we have, similar to the substitution reaction, we have the halide, which we say is lost as the leaving group. Now, if the reagent, that is the nucleophile or base, if the reagent can act as either a nucleophile or a base, what we typically observe is the production, the formation of both the substitution and elimination products. And so there's a competition that will result because the reagent can take on both identities. So for example, in this example where we have 2-chloropropane reacting with sodium hydroxide, of which the active ingredient, the key species, is the hydroxide ion. Recall our section on counterions and how they play no significant role in the mechanism of reactions. And so with a hydroxide ion, in this example, can both be involved in the production of an elimination product, i.e. the alkene, or we can form an alcohol. And in both cases, what is lost as a side product is the chloride, which is shown here as the salt, which could be more accurately described as Na+, and Cl- the chloride. Now similarly below, what we're observing here is another alkyl halide, which again, you can see that there's two possible outcomes, alcohol formation or alkene formation. So this is typical for some alkyl halides, depending on the nature of the reagent. Now there's two main reasons why alkyl halides like these undergo substitution and elimination reactions. And so it's important to recognize why the reactivity is even observed. And as we've talked about previously, the nature of the polar covalent bond has a large importance or a lot to do with why these reactions occur in the first place. So because the halogen is so electron withdrawing relative to carbon, we know that that carbon will have this partial positive charge associated with it. And so as a result, that partial positive charge makes that carbon more susceptible to nucleophilic attack. As you can see here, the nucleophile is attacking that electropositive or partial positive charge on carbon. And that carbon, again, is referred to as the alpha carbon in this particular reaction. The second reason why alkyl halides undergo these types of reactions is that the halogen can act as a good leaving group via the halide. So we've seen in the previous example, the chloride or bromide, but this X minus representing the leaving group for the alkyl halide. And so for a substitution or elimination reaction to occur, it must have a potential for a good leaving group. And by definition, a good leaving group really is a stable base, a stable conjugate base. And we can relate back to our section 3 to identify what characteristics give rise to that type of stability. So shown here in our diagram, or in table 7.1, is a list of really good leaving groups. And as you can see, the best leaving groups are the conjugate bases of the strongest acids. In particular, our halides are very good. So our iodide, bromide, chloride, these are excellent leaving groups. And so this is why the alkyl halides can act as good substrates for these types of substitution and elimination reactions. In addition, another commonly used leaving group, which is sometimes referred to as a pseudohalide, in the sense that it's not a halide, but acts as a very good leaving group, is the conjugate base of this acid, para-toluene sulfonic acid. So the conjugate base of this acid is known as this para-toluene sulfonate, which is shortened as a tosylate or toisylate. And it is often abbreviated, as shown here, in addition, you can see that water is also considered a decent leaving group. And so what's highlighted in green in the top section of this table are some of the best leaving groups that we will often observe in these types of reactions. Now on the flip side, some of the worst leaving groups are the strongest bases. And so the hydroxide oxides, such as the ethoxide and tertiary butoxide shown here, and even worse, the amide ion, NH2 minus, these are some of the worst leaving groups available. And so we wouldn't expect substrates that have these types of groups attached to them to undergo substitution or elimination reactions. Now what I've done here is I've tabulated the various leaving groups and ranked them from excellent to very poor based on various sources or various organic textbooks. And as you can see, the tosylate is one of our best leaving groups, followed by the iodide. And then we start to, in the middle of the pack, we have our good leaving groups, water, neutral water, the bromide. And then some of our okay leaving groups, maybe the reactivity will be a little bit slower, but the chloride and, the acetates and other types of carboxylate salts. So in general, again, species that are able to stabilize the negative charge due to a size effect, or species such as water, which are neutral and very stable, again, the best conjugate bases in terms of stability are going to be those that come from our strongest acids. So if you have any questions about some of the general aspects of substitution and elimination reactions, or what makes a leaving group a good or poor leaving group, by all means, send me an email and we can set up a Zoom appointment if necessary. In the coming videos, we're going to look at substitution and elimination reactions in greater detail. Thank you.